Today we are going to see example on anonymous methods. Okay, so first we'll discuss how to write a program with all the three techniques. This is one logic, hash using system, class, program, public, static, void, main. And I write here console.writeLine sum of 12, 23. Then we write a method public static int sum int x int y block open return x plus y. This is called named method and direct call. This is one technique. Now, same program, second technique. Using system, class, program, public static void main. Then here I write delegate int test int x int y. This is signature of the delegate. Test t equal to new test sum console.writeLine t of 12, 23. Then you have to write public static int sum int x int y. Return x plus y. This technique is called named method because we have a method for the name, and it is indirect call. Third technique, using system, class, program. Now I write public static void main. Now here I write delegate int test int x int y. Then we write test t equals to delegate int x int y block open return x plus y. Then here I write console.writeLine t of 12, 23. Now in this technique we have unnamed method plus indirect call. What we did here is, in this anonymous method, what you did is this part we reduced now. We have made a part of main method. Which part? Which one? This part. this part. I moved to main method. That int x into y return x plus y. That part we moved to main method. That is the reason there is no separate method called sum. There is no separate method called sum. Unnamed method, or it is also called anonymous method. Unnamed method or anonymous method. Anonymous method. Yes, three logics. Same program, three approaches we implement. We implemented with the direct call and we have a name for the method. And second logic is we have named a method and we have called indirectly using yesterday's class topic, that is using delegate. And today we made a method available within main method preceded with the delegate keyword. Preceded with the delegate keyword. Okay, and you can see that we are still calling a method indirectly only. We are still calling a method indirectly. Okay, this is a program for anonymous methods. Now, next topic we study, it is for lambda expression. That would be our next topic. Lambda expression. Now, for lambda expression also, similar thing I'll prepare. I'll try to write a program in the paintbrush comparing with comparing the logic with four codes, four blocks, four different logic. I mean, four codes we'll try to make now. One beside the other I'll make, so that comparatively you could make a difference. How it differentiates in the concept of lambda expression, how it goes. Okay, now let's go with this. Now, this is lambda expression. Using system, class book, void main, and I write console.writeLine area of circle 7, and I close this and I write a method public static double area of circle double radius, and you have to write the formula return math.py into radius into radius. What is this technique called? It is named method and direct call. Named method and direct call. One program. Then same program, another approach. Same program. Second approach. Okay. And what is that approach is? Same code and same. चलो right. First I write as usual using system class program public static void main, and here I write delegate double test double radius. Then test t equal to new test area of circle console dot write line t of 7. Then I say public static double area of circle double radius block open return math.py into radius. And what is this technique called? Named method and indirect call. Named method and indirect call. Now using system class program, then I write delegate double test double radius public static void main. Then test t equals to delegate double radius block open. Here you open the block and write the logic. Return math.py into radius. Close the block. Then here you should write console dot write line t of 7. Then close main, close class. And what is this called? Unnamed or anonymous method plus it is indirect call. Third, same program, three logics. Named method direct call, unnamed method indirect call, and unnamed method and indirect call. 3. Now I'll show you same program how it will reduce if I go with lambda expression. Same program, same. Now see how will be the reduction of code now. Yes, this is for lambda expression. Using system class program block open delegate double test double radius public static void main block open. Then you require to say test t equal to here radius, that is input. First radius which you have written, it is input, and then equal to greater than, it is called goes to operator, GOES, goes to operator. And after that, you require to write the logic. Math dot pi into radius. Simply you have to write console.writeLine T of 7, close main, close class. And remember, this technique, whichever you have written, it is lambda expression. Same program we have attempted in 4 ways now. Same program, same program. And you can see a drastic change in the code. Drastic change. That is the reason lambda expression is always called inline method. Lambda expression. That operator is called goes to operator. Goes to operator. GOES, goes. TO2, goes to operator. Total method, I mean to say, 1, 2, 3, 4 lines of code we compressed to single line. Single line. That is the reason why we called lambda expression is an inline method. Inline. It is we are creating what? Local function. Local function. And what is missing? There is no method name, there is no return type, there is no body. All are missing. There is no return method name, no return type, no body. All three are missing. All three. Yes. This is named method and direct call. This technique which I have implemented now. And this is named method and indirect call. And this is unnamed method and indirect call. And this is lambda expression. Lambda expression. 4 topics. Now, we have another concept that C# supports to work with something called built-in generic delegate. Built-in generic delegate. That part we'll see now. Okay, in this only I'll cover comparatively. That would be more easy. Okay. Built-in generic delegates. 3 topics. In this we have 3 processes under this. First one, let me write here. First technique is FUNC parameter 1, parameter 2. And here something important to learn is parameter 1 is input, parameter 2 is return value. That's this part you remember. How to write, I'll show the code. First, using system, class, program, block open, public static void main. Then I write func double comma double. What does it mean? First double is input, second double is return value. T equals to radius goes to math.py into radius. That's direct. Console.writeLine. I can say T of 7. That's what is that you find is there is no delegate in in specified in this program because func itself is a built-in delegate, built-in that to generic delegate. This is one part over. Second part, second built-in generic delegate. Second one that is called action delegate. Second one. Second is called action. First one, what did you say? First one is function. Second is action. How you work on action is using system, class, program, block open, public static void main, block open, and I write action string TWL shortcut input. This is y is input, and I write console.writeLine y. See what will happen. Now you have a concept where you can say welcome to programming best TWL. Thank you. So you can see that we have renamed console.writeLine to CWL by using action delegate. Third one we have is predicate delegate. And how predicate works? Always predicate returns Boolean value. Class program public static void main. Then you can say predicate string C assigns to x goes to x dot length greater than 5. What is x? Input. X dot length, whatever input I give now. What is that input? You see now. Console dot writeLine C of Sharif. If I say, you know what exactly it means? Sharif will be sent as parameter. So x will receive Sharif. Sharif dot length 7. 7 is greater than 5. True. So now remember console.writeLine will return true. Means predicate always returns Boolean value. Predicate always returns a Boolean value. Okay. Now three delegates we have. Exactly same way. Now we are going to learn one more topic for delegate that is called expression trees. Now, you know what is the importance of expression trees? In expression trees, we are going to perform arithmetic operations, plus minus into division, all arithmetic operations without using arithmetic operator. That is special task. Okay, how would you do this? Like, I want to calculate values like this. See, my expression is in this way. 18 plus 20 minus 10 plus 12. This is my expression. I want to calculate this. How would you do this? Things go like this. For my expression, second expression, third expression, fourth expression. Yes, link all of them. This is connected to this. This is connected to this. This is connected to this. Connected to connected to. Now, here first comes minus, then plus, then 18, then 20, then 10, then 12. Minus, plus, plus, 18, 20, 10, 12. How you represent is minus you represent for subtract, plus you represent for add. Subtract, this is add, and this is add. Now question is, how do you write a code for this? And I already said you are not supposed to use mathematical operator. I mean to say like arithmetic operator. And you should perform the evaluation of this expression. How do you write? First, using system. Second, using system dot link dot expressions. One namespace required. Why I'll say why do you need this? Class program block open. Public static void main block open. Binary expression b1 equals to new binary expression. No, this is not no. Binary expression is a class that is available in that namespace, expressions namespace. System dot link dot expressions namespace is in that namespace we have this class called binary expression, and in that there is a class called expression dot make binary is a method. What do you want to do first? You want to add now 18 plus 20. So we write expression type dot add, comma, expression dot content of 18, comma, expression dot content of 20. Yes, this total meaning is 18 plus 20 now. This total meaning of this line is 18 plus 20. Then second expression. Binary expression B2 equal to expression dot make binary expression type dot add. Again, I should say expression dot constant of 10, comma, expression dot constant of 12. Yes, this is second expression, that is 10 plus 12. First one is 18 plus 20. Second is 10 plus 12. Then third one, binary expression B3 equal to expression dot make binary, then expression type dot subtract, comma, B1 P2. Now the meaning of this statement is 18 plus 20, 18 plus 20 minus 10 plus 12. Meaning of this line. Over. Nowhere we have plus minus operator. Everything we are trying to do without using arithmetic operator. Then to store result, res is equal to, now you can say expression dot lambda of of method it is actually, I better write like, I'll write like, okay. And lambda is generic it is. So you have to write func, right? Which type of calculation you're doing? Integer type. Close this generic. Which expression you want to use? B3. B3. And what do you want to do? You want to compile. Compile is a method. Yes. Simply you have to write now. Console dot write line result is plus res, close make, close. That's it. This is how your expression tree. How did you make? Using lambda function. Available in which class? Expression class. Where are all these classes? System.link.expressions. In that we have. Okay, did you understand? But it requires practice. You have to go through this all topics